Hello, everyone. Welcome to the Science Cafe. I'm Drew Cannon. On Friday, February 19th, 2021, we streamed live from the beautiful Verde Valley here in Arizona and had a discussion about climate change and its impact on Arizona agriculture, and specifically grapevines, with our guest, Dr. Jeremy Weiss. We had a few minor technical difficulties during the recording of this event, resulting in no video of our guest, and my introduction was not recorded. However, the entirety of the audio discussion with our guest, except for perhaps a couple of minutes, was captured and recorded. At this point, I will recreate my introduction, and then I'll let you know where the recording from February 19th, 2021 begins. Before we begin this evening, for those who aren't familiar with the concept of a science cafe, it's kind of a movement springing up in communities nationwide where we invite individuals whose field of study and careers that are related to STEM, which is an acronym that stands for science, technology, engineering, and mathematics. So they meet with you and me, the public, in an informal setting outside of their labs or classrooms in order to just have an informal conversation about their cool research and projects. Our Science Cafe here in the Verde Valley is hosted by the Verde Valley STREAM Council, which is a part of the Rural Activation Innovation Network, also known as RAIN, and is made possible through a grant from the National Science Foundation. Their mission is to develop and support partnerships that help shift cultural awareness to target and enhance informal STEM learning for all ages here in our rural community, right here in our home, right here in the Verde Valley. Before COVID-19, these sessions might meet in person in a relaxed environment, such as at a coffee shop, a restaurant, or perhaps even a wine tasting room. But for now anyway, we're doing it virtually from the comfort of our homes. So go ahead and relax, grab a beverage or snack, and let's enjoy an evening of conversation. We want to encourage you to ask questions. We hope you have many this evening. This is how it will work. Please use the Zoom meeting Q&A box to enter your questions, and I'll relay your questions to our guest. So let's talk about our topic this evening, climate change and grapevines. I know we have some folks in our audience from outside of Arizona this evening, as well as some folks from Arizona who perhaps don't realize we have a developing and thriving wine industry here in Arizona. Here's a fun fact. Arizona at one time had a more developed wine industry than California. Arizona went into and out of statewide alcohol prohibition that was one of the most restrictive in the country over an 18-year period. Federal prohibition was only 13 years. So Arizona lost a few years, and we're still in the process of catching up. Here's another fun fact. One of our native grape varieties is here in Arizona and is called Vitis arizonica. It's also known as the Arizona grape or the Canyon grape. And I'm serious. It still can be found growing here, right in the Verde Valley, in our riparian environments near our local rivers, including the Verde River. Now, our modern palates would probably dissuade you from wanting to eat or make wine from these wild grapes, although the local residents did in the 1500s. But the fact is, grapes grow here, and they grow very well. Some very nice, award-winning premium wines are being made by our many talented winemakers from the excellent grapes being grown throughout the state. Here's something else to consider. The Arizona Office of Tourism, in a 2017 report, estimated that the total economic output of the wine industry in Arizona was more than $56 million, and more than 640 full-time equivalent jobs were created. This represents about almost 50% increase in total economic activity over a 6-year period. This report was generated more than 3 years ago, so these numbers have increased since then. The wine industry is important to Arizona. Now, to set the stage for our conversation, we typically denote the wine regions of the world lie between 30 to 50 degrees latitude in both the northern and southern hemispheres of the planet. Arizona falls within the very southernmost part of that band, but not all areas in Arizona are conducive to growing grapevines. For example, Phoenix and Tucson. Those areas are just too hot for commercial vineyards, or Flagstaff, which is on the other end of the spectrum. There are also examples of outlier wine growing regions that fall outside of the band, such as in Mexico. And those growing areas are located in regions that are at higher elevations. Climate change. It's an important topic to discuss here in Arizona, especially as it relates to agriculture. Remember, we're in that southernmost region of the wine grape growing band. So how does climate change impact wine grape growing here in Arizona? So our guest this evening is Dr. Jeremy Weiss. He's a climate and geospatial extension scientist with the University of Arizona Cooperative Extension in Tucson, Arizona. Welcome, Jeremy. Thank you for joining us this evening. Briefly, I wanted to mention how we met. I earned my degree in viticulture and enology. Viticulture is the study of how to cultivate grapes, and enology is the study of winemaking. So I earned my degree from Yavapai College at the Verde Valley campus right here in Clarkdale, Arizona. Yes, you too can learn how to do this. So we met at the Climate and Viticulture Exchange at Yavapai College in June of 2018. And we've kept in contact, especially through the Climate Viticulture newsletter that you and your research partner, Marie Blanche, produces. A really valuable resource. And we'll talk a bit more about that in a minute. So, before we talk about climate change, we should start with a basic foundation. What do we mean when we talk about the climate? What is the climate? And how does that differ from the weather? So, at this point, we continue with the original recording from Friday, February 19th, 2021. Thank you again for joining us.
Of weather over a period of time. It's also referring to extreme events and their frequency. And it's also referring to any trends that you may see in the weather data over, again, a period of time. And so it's quite wide ranging. And having come up through the universities studying climate, for the master's and the PhD degrees, it really, it's not just the atmosphere, really. It's the entire Earth system that is all hooked together in some way, shape, or form, much like the human body is attached from the foot to the head in some way, shape, or form. And different parts of the system, like the oceans, influence what the atmosphere does. For example, this winter, we've had a moderate La Nina event. And what that means for the Southwest is that there's a tendency for drier conditions during the winter months. And the La Nina event, if we're thinking about the climate system, it starts with how warm the sea surface temperatures are in the tropical Pacific Ocean, and how that's connected to some of the atmospheric circulation over the equator in that region. And so changes there reverberate and knock the jet stream into a different position, and that's kind of how it all works, and in a really simplistic way. So just this interconnectedness of so many different things.
Mm-hmm. And so now, what is climate science then?
Well, there we're starting to try to figure out, based on what we observe, how does it all work? The El Nino and La Nina events that we know here from the Southwest as having some influence on our weather, they weren't always known. It's only really been 3-4 decades really that the science has been developing on that phenomenon. So again, it's really trying to take apart our observations and figure out, excuse me, how things work, how things interact, and how things in this, in the case of present day, how things might be changing and why.
Right. So now, Jeremy, we very likely have some students in our audience, and I think the academic path you took is really interesting. Um, if, correct me if I'm wrong, but you got your Bachelor of Science degree in botany with a focus on horticulture. Is that correct?
That's right.
And then as you went for your advanced degrees, you studied earth and planetary sciences and geosciences, which, you might initially think, how did they connect? But clearly, when you talk about climate change and effect on grapevines, viticulture, it fits. How did you become interested in those fields of study?
Well, like some people, when they go to college, they have absolutely no idea what it is they're supposed to study. And I actually began up at Northern Arizona University in Flagstaff. And as is the case with probably hardly any of those people going to school and not knowing what they're going to study, I jumped into mathematics. And not too long after starting, changed course a bit and started dabbling in environmental sciences. And then I saw a course catalog from ASU, and the botany and the horticulture program there got my attention. And so I decided to transfer. Um, from there, as you mentioned, off and on, as far as being in school, I'd take breaks between degrees and work for a bit. Yeah, I started getting into the climate field, and it's kind of funny, that I alluded to a little bit ago, the complexity of what makes the climate on the planet, and it's really reflected in climate science because it's like the types of doctors that we see in the world today. I have some that are foot and ankle specialists, others are experts in heart surgery, others are they're optometrists. So just like that, because climate is so complex, when you look at it in its entirety, there's about that many flavors of climate science and climate scientists that are out there. So I hopefully found the best flavor of climate science for me, and have stuck with it. And yeah, here I am.
So, do you have a recommendation on how a student should prepare in order to study for a career in climate science? What do you recommend? Like if someone's in high school or kind of doing those pre pre pre-education courses to prepare for college?
Yeah, I think since there are so many different ways to approach climate and climate science, um, having a good idea, because you can explore. Because honestly, when I got out of high school, I had no idea what was out there in the world, and I think even now it's hard to imagine all the different areas in which you could work, study, and eventually work that relate to climate. And if you're super good at math and physics and enjoy differential equations, well, then you can go into that part of the field where you're going to be thinking about how to put models together. A lot of that has to do with programming, computer programming as well. So if those are your skills and your strong suits and your interests, that might be the branch to go into. Other areas are much different, and what I see happening, especially in the last few years, is opportunities working in the field of climate generally, but that are in financial risk and in the financial industry. A lot of positions now that I see opening up in the past few years also are dealing with sustainability. Companies are thinking about issues of sustainability, and that falls under, well, I got my umbrella upside down here. The umbrella of sustainability does have a climate component to it. So there's a really wide range of potential topics and fields to go into. And so if you were a student nowadays, whether you're in high school or maybe you're just finishing up your undergraduate, maybe you're interested in graduate school or pursuing some additional education in some form, take a good, take some time and take a good look at all the possible opportunities that are out there, because it's like I said, in the past few years, it's just really exploded in terms of the different areas, different types of businesses, different topics that are thinking about climate.
Okay. And, does the University of Arizona have a degree program or programs related to climate science? And if so, what are those? What is that program or programs called? How would they find out more about that as well from U of A?
Yeah, so a good place to go on the University of Arizona website would just be searching for environment. And as I alluded to a minute ago, the areas, the disciplines, if you will, whether you're in hydrology or natural resources or rangeland management or you name it, a lot of those areas are doing applied work in the context of climate and climate change nowadays. And so it's really widespread across campus in terms of which department or degree you could do and still be working on some aspect of climate or climate change in your field. And so, again, if you're into math and programming, atmospheric sciences might be the best department for you. I'm housed or based on campus within the School of Natural Resources and the Environment. And so if ecological applications, rangeland applications, if you're thinking about wildland fire management in the Western United States, and you want some context with climate and climate change, maybe that's a good department for you. So there are a lot of different avenues possibly to go down here. And it's really worth taking the time to explore and kind of get your bearings and get a good sample of what's out there in relation to your interests. And just start talking to people. People on campus, they're often, each department's going to have an academic advisor, faculty, staff that are going to be very interested in talking with you if you're interested in coming to campus and pursuing your interests in one field or another.
Okay, great. And so now we talked about what is climate and what is climate science. So what is climate change? And I know we could probably talk a month about that, but in a nutshell, how do we describe climate change?
Well, when I did my climate studies at the U of A about 10 years ago now, I was actually in the geosciences department, and a strong focus there is actually on paleoclimate. So you're thinking about things like tree rings, lake sediments, even ice cores, ice cores, and you're looking at climate over the thousands of years. And so oftentimes those natural archives, as they're sometimes called, are looking at how the Earth's climate has changed, natural variability in change, over millennia. Of course, when we're talking about climate change nowadays, what we're really referring to is how human activities and emissions of greenhouse gases, such as carbon dioxide and methane, are changing the composition of the atmosphere and basically enhancing or intensifying its ability to trap heat within the atmosphere. And so that heat or energy's got to go somewhere, and as you can well imagine, it's got to have some kind of an effect. Basic physics there when you add heat to a system. And so when we're talking about climate change, and as we're talking about climate change today, it's really referring to what's happening right now, human influence, and as things continue, in the coming years, we're going to have to think about how is this system changing? How is climate changing? How is that affecting us? Are these effects good or bad? Can we adapt to them? How do we change what we do to keep our systems operating, whether that be transportation or energy or what have you, and try to still have some kind of prosperous, progressing society, even though the environment is changing with us. And of course, there's also a mitigation aspect. How can we change how we do things to lessen the total amount of climate change that we would experience over decades and, to be honest with you, over centuries, because it takes a long time for the Earth to go back into equilibrium with that kind of jolt to the system in terms of trapped heat and energy. And so it's not a really nimble system in that sense. It's more like that Titanic. It's going to take a long time to make a turn.
Mm-hmm. Okay. And a frequent topic of discussion is anthropogenic or human-influenced climate change. Do we know what percentage of the average increase in temperature is a natural cycle versus anthropogenic climate change?
Yeah, the short answer is that it's overwhelmingly human. That is well known. And I'm going to put should I put it in the chat box? A link that I like to refer to, because even though we're talking in large part about human caused climate change, natural, it's not that the Earth's climate has suddenly changed into something we don't know anymore. There's still natural variability going on and natural changes going on, but the signal of the influence of what the human caused aspect of it is much larger than the natural. And so I put a URL in the chat, and I encourage everyone to check it out if they feel so inclined. And basically what it does is it walks you through, it shows you what the global average temperature has been over the past number of decades. And it goes through all the individual natural influencing factors like volcanic eruptions, solar variability, and shows you, okay, what science knows about these natural forcings, as the jargon is, or these natural influences on climate. What we would have expected over the past, say, century, and then that shows you what the temperatures would look like. And then it goes into the individual human influences on climate, such as I mentioned earlier, emissions of greenhouse gases, but also things like deforestation. And so, what the activities we do, what influence what we would expect those activities to have influenced the climate, or how we would have expected them to influence the climate. And then at the end of that, it's a data visualization. It's actually quite well done. At the end of it, they synthesize everything together and say, hey, this is how the science views everything. And so the point there is that, even though that data set ended in 2015, things have the trend that's evident in that graph as far as global temperature is concerned is continuing. And I've always come back to that to explain things, because it just gives you such a nice visual. It goes through the individual factors. And I think it's just a really clever way to help understand that question. What's the natural system doing? What's the human influence part of things doing? And it's just a terrific data visualization.
Great. Now, the term global warming was used quite often a few years ago. Now you hear the term climate change is being used more. Are there distinctions between those two terms?
I'm sure there is. I'm not a linguist, but I should ask my wife about that. She is. Real quickly, Drew, I'm seeing things in the chat about the URL not showing. I don't know if I did put it in there, but I'm sorry. I had it on the direct message to you. I'm going to change it to all panelists and attendees. Thanks, folks, for catching that. My apologies. Hopefully now you can see it.
Can everyone see that?
There it is.
Okay.
Yes.
Good.
Bravo. So back to your linguistic question. Yeah, you hear global heating, global warming, climate change, different phrases used. In general, I think they're all pointing at the same issue. Perhaps global warming is, in a way, one might argue, kind of limiting, because it's just thinking about temperature. But as we know, and as we've already observed, the changes to Earth's climate aren't just temperature. Certainly the temperature, we have observations of warming temperatures in regions around the world, and especially in the Arctic. And, those of course have effects. Atmosphere becomes warmer, the ocean has become warmer at, all, depth throughout the profile of the ocean. And some measurements have shown things, but we also are observing changes that are consistent with what we would expect from a warmer atmosphere and all the physics involved therein, as far as the nature of precipitation changing. A warmer atmosphere, as it's often said in a lot of science types applications, holds more water vapor. It just has the capacity to hold a larger volume of water vapor. And so what that means is that when it does rain, there's that much more water vapor that can be squeezed out of the air as precipitation. And that means that when it comes to extreme events, the possibility now is there that the extreme events actually are going to reflect a higher precipitation amount. So if your 1 day maximum total and some day in the past had been 2 inches, maybe now with warmer temperatures, it possibly could be 2¼ inches or 2½ inches. And that may not sound like much, and in some cases it probably wouldn't be much of a difference, but once you start thinking about things like how stormwater systems are designed and engineering aspects, where culverts are, the diameter of a culvert underneath a road is going to be a function of the historical precipitation record. Well, if we start getting bigger precipitation amounts or greater precipitation amounts that are above what we've seen in the past, and we do see this occurring, there is a potential then for that stormwater system to be overwhelmed and not be able to handle the stormwater. You might have roads washing out and so on and so forth. And so you can start to see all these knock-on effects, cascading impacts, as they're sometimes called. And that suddenly becomes a much greater cost to society, because then instead of having just a minor delay from maybe some ponding water in a road, suddenly the road's washed out and it has to be replaced. And those things aren't that cheap, of course. So that's kind of a bit of a winding answer to your linguistic question, but those are the kind of things that, so in essence, climate change may be more a better description of what is going on, because so many aspects of our environment and of the climate system are changing. It's not just temperature. Of course, temperature changing has a lot of those impacts on all sorts of components of the rest of the system.
Now, clearly, based on your description, climate change involves a lot of different variables. So what types of data are used to study and forecast climate change?
Well, I mentioned paleoclimate and some of the natural archives. That's like tree rings and sediment cores from lakes and ice cores. Those have been incredibly valuable in helping us frame what the natural system can be like, and what big changes it has gone through in the past under natural conditions. So we have, looking way backward, we have the paleoclimate. We also have a lot of historical observations, and those are things that everybody this day and age is used to. Observations at meteorological stations, and there's ship tracking data sets that are out there for getting measurements over the oceans. Those are modern history. We have our standard weather forecasts, although that's not exactly what we're talking about here. It does fall into the general arena as far as, once we start looking forward, we have the weather forecasts. And in terms of looking distantly, and you might hear a lot of, or read a lot of, by the year 2100, scientists are expecting or anticipating conditions to be this way or that way. Those are based on what are called climate models. And I'll try my best not to get in the weeds on a Friday afternoon on that one. But I'll try to describe it so people can appreciate the difference between climate projection models and the weather forecast models. When it comes to the climate projection models, these are, let's see, how to best say this. We're talking global models. I think upwards of 36 different research institutes around the world have their own climate model. Close to 36, I think it is. And as I was mentioning earlier, when it comes to climate, it's the entire Earth system. So in these global models, they have an atmospheric component, they have the ocean component, they have land surface components, they have the cryosphere components, that being the poles, ice-covered surfaces. It's not just a two-dimensional globe. They have numerous levels into the atmosphere. So from the lower atmosphere, right by the surface, all the way up, above the range of the atmosphere in which weather occurs, up into the stratosphere. They go into the depths of the ocean at many, many different layers. And so these models are made up of a lot of math, a lot of physics, and what they do is say, okay, we build these models initially based on our best understanding of how the natural system works. All of our understanding. It's a lot of science going into that. And from then they say, okay, well, what we're going to do is test how, if we increase greenhouse gases in these models, what does the Earth's climate do? Which way does temperature go? Which way does precipitation go for a region or continent? And so what we're doing is really testing, if you will, the sensitivity of the Earth's climate to these big perturbations, changes in things that force it or drive it. And you could do the same thing with some of the natural forcings too. If you wanted to tinker with solar variability, you could do that in the model and see what effects it has on Earth's climate. And so they do those experiments. They also do them, of course, with greenhouse gases. And those are the foundational data sets with which a lot of different assessments, whether it's at the international level, the national level, or even the regional level in the United States in this case, those form the foundation of what we use in terms of how we analyze things and say, okay, we know a lot about this part of the climate system. The projections are showing us it's going to change in a certain way. Our confidence is pretty high that, yeah, that's where we should anticipate things heading. Other parts of the science, these models aren't perfect. They're incredibly amazing with the realism that they show. But of course, science is an evolving field, and we don't have differential equations and other mathematical formula, and we don't understand all the physics, and there are some other constraints with the models as far as how fine a spatial resolution we can actually use, because these things use supercomputers and they run for a long period of time. They're incredibly expensive to run. And so we can't have individual houses in a neighborhood showing up in these models. These models have to be somewhat coarser in their spatial resolution in order for us to get the job done. And so some of the things science still hasn't figured out. But a lot we know a lot already. And it's just a case of, we know we're affecting things. And so we have all these anticipated impacts that we see. And we can act to address those, whether we adapt to them or whether we try to mitigate them and not have them happen. That's our choice as social, as a society. So, not to get into that topic as far as what we should do about things, but yeah, that's what we use. We use these incredible models that I didn't go that down that branch of climate science. I the differential equations they were a little too much for me.
Well, and just as an aside, I just read an article from February 20th of last year. The National Oceanic and Atmospheric Administration announced they signed a contract to purchase 2 new supercomputers from Cray Computing, which would triple the computing capacity of the machines devoted to running that agency's weather forecasting and research models. So by the time those machines are up and running in 2022, that agency will have a total of 40 petaflops, and that's computing speed equal to 1,000 million floating point operations per second of computing capacity dedicated to running about 24 operational computer models, from the Global Forecast System, GFS, to the Short Range High Resolution Rapid Refresh, HRR model. So really the most powerful computers and complicated algorithms that's ever been developed are being utilized to analyze this mind-boggling set of climate data. So anyway.
Yeah, no, that's a great point. I mean, you have this technology, computational technology that's being developed, and yeah, we're applying it with these global climate models, but we're also integrating them in aspects like the weather forecasting models that we use, which those the climate projection models kind of they start at a point in time, and then they're just let run, and often that point of time is some years in the past. With weather forecasts, of course, we're starting it with the latest observations, as many as we can get in there, to make sure these things are tied to our current conditions as accurately as possible, and then we just run them for a short period of time, and so we can kind of narrow down what the possibilities in the future are. So as far as our weather conditions over the next week to 2 weeks, but yeah, it's really amazing. The amount of computational power, and not only that, but there's just the amount of data that's produced is incredible.
Yeah. So now let's talk about viticulture. So according to the data, what is the forecasted impact of climate change to Arizona's agriculture and specifically viticulture? So, and for those of you who don't know, viticulture is the study of and practice of cultivating grapes.
Yeah, there's for the Southwest in general in agriculture, I'm looking for a link that I think will be helpful, and this time I'll be sure to send it to everybody. This is volume 2 of the most recent National Climate Assessment, so it's just a couple years old, and in there they have various chapters, and one is on the Southwest, and some of the points that they make are related to agriculture in the Southwest. When it comes to climate change impacts on agriculture in the state and the Southwest more generally, it's really related to water resources. That's a really big part of it. We've had a number of dry years, the past couple of decades, really. And although that has been part of natural variability, this region has been plagued by droughts, and even long-term droughts over 2-3 decades, if not longer, throughout the past several centuries. And again, that's where some of that paleoclimate data and analysis comes in to be really valuable. We understand these things have happened for a long time. We should expect them. But the kicker in the last couple of decades has been that regionally temperatures have been warming. And so with a warmer atmosphere, all else equal, that's going to drive more evaporation from pulling moisture out of the soil. It's going to make the plants transpire that much more water as they photosynthesize. And so things dry out faster. And so some of the work that I've done in the past and that a lot of other people have also worked on, has been looking at this as the Southwest warms, water resources do decline. And, some of that is wrapped up in demand and population growing in the region, but also some of it is that the supply is going down. And so for different reasons, natural drought, warming temperatures, as I just described. So it's, water resources are declining to an extent. And in terms of viticulture, that's a big thing because we have to irrigate here. Very few occasions, I think, one would be able to dry farm wine grapes in Arizona. Just because we don't get enough precipitation, especially at the lower elevations, but even at the upper elevations where cool climate viticulture might be possible, it still might be too dry to dry farm wine grapes in this state. So we're left to irrigate. And if recharge into an aquifer isn't as much, if the vineyard is, for all else being equal, under warmer conditions, it's not going to be as water efficient. And so, there's that water resources issue. That's one big thing. But of course, when it comes to wine grapes and viticulture in Arizona, I think the other big thing is that temperature has an incredibly large amount of ways, or has many ways that it can influence the composition of the fruit during the ripening period, for example, that ultimately is going to be reflected in the bottle of wine. And so are those changes going to be good? Relatively higher sugar levels, relatively lower acidity level, degradation of anthocyanins. That might change the colors of your wine. Other aspects of the phenolic and aromatic compounds in the wine can change as well. And these have been documented in other growing regions around the world. So the question is, okay, are these changes good, bad, or neutral? Can I still make a good wine with what I'm pulling out of the vineyard or with the grapes I'm buying from somebody who's growing them? And not only that, but of course, if those changes are detrimental, then you have to start thinking and worrying about sales. Well, maybe I can't charge as much for that bottle of wine because some of these changes that are occurring as temperatures are increasing aren't good. Maybe you don't sell as many bottles. And so I think when it comes to viticulture and climate change, two big things: water resources and quality, the composition of the fruit coming out of the vineyard. Those are the two big effects. I think that from what I've read and what I understand are here in Arizona. And in Arizona, a lot of what we grow is warm climate viticulture. And so the effects of temperature on the fruit have, a lot of those effects potentially could be negative. Again, seeing sugars go way high, the acidity drop, the wines become unbalanced. And so warm climate viticulture has some challenges to address this, I think. But on the flip side, you can think of cool climate viticulture. Well, why all of a sudden is sparkling wine a wonderful thing in Southern England? Well, it's finally gotten warm enough there to ripen the fruit to produce a quality product. And the growers in Champagne, France are looking at Southern England and buying property there because they see where the changes in the environment are leading to, the changes in climate for viticulture in this case. And, they're looking 10, 20, 30 years down the road and seeing, well, that's where the opportunity is going to be. We're going to be challenged here at home because conditions won't be as optimal, but in these other growing regions like Southern England, in this case, in this example, things might be better. There's a large grower in Spain who is buying property 1,000 to 2,000 meters up, 3,000, 5,000 feet, 6,000 feet higher than where they are right now. Not because they're growing there now, but because they know in 10, 20 years, it'll be warm enough at those higher elevations to grow wine grapes. And of course, down in the lower elevations, where it's warm climate viticulture, challenges that I've described, they're going to be facing them as well. Warm climate growing regions around the world. And they're kind of hedging their bets, making sure that they got something that's still going to work in 10, 20, 30 years down the line.
I had an opportunity to travel through Washington and Oregon, and I was surprised how many vineyards there are starting to grow some of these warmer grape varieties that we see here in Arizona. The Italian, the Spanish, and Rhone region in France. And I'm curious if they are also starting to plan for the future.
Oh, they most definitely are. I gave those two examples with Champagne, France, Southern England, and that example in Spain. Southern Rhone is having trouble with Syrah because it's become too hot for producing the Syrah that they want to have in the bottle. And so that's become an issue for them, and they're replacing it with something that is more heat tolerant. Bordeaux is another example. They just approved in past few months, I think it was, 7 new varieties that they can grow in their appellation. And some of those, I think, if not all, I think at least half or more are coming from Portugal, like Touriga Nacional. They are planting them on a limited basis, but they've approved them to be planted in the Bordeaux region because they offer the same type of qualities that previous Bordeaux vintages have had, but are starting to lose the typical Bordeaux. We're talking Cabernet Sauvignon, Merlot, Sauvignon Blanc. They're starting to lose the qualities that they like to have in those wines, and so they're trying. And a lot of that's related to temperature and the effects on the fruit composition. So they're bringing in these other varieties ahead of time in a way, because yes, they can still make wine with the previous varieties, but they want to make sure that they're not caught on the back foot, and they have so that, instead, they want to be thinking ahead and being proactive and having these alternatives in place long before things get particularly bad in terms of the wine quality that they produce. And for them, of course, it's a business, it's sales. So they don't want the reputation to be damaged. They want to keep things where, their position, their relative reputation.
Right. So what are some, we've kind of touched on this, but what are some recommendations for current and future Arizona vineyard owners to prepare for these forecasted impacts? You mentioned adaptation. I noticed in the February newsletter, there was a comment about heat tolerant, drought resistant plant materials. Do you have thoughts on that?
I do, and these are just some of the tools in the toolbox. And of course, when it comes to the use of the tools, not everybody is going to use the same tool set. Each vineyard is its own unique situation, has its unique history in a way, its unique environmental conditions. But some of the tools range from what you just mentioned, thinking about, and as I was describing earlier, this relative decline in how efficient the vineyard is with water, all else equal, just because we're losing more to evaporation and more through transpiration during the growing season. So we could start with the rootstocks. There are drought-tolerant rootstocks. If you're putting in a vineyard and are grafting called varieties onto a rootstock, the scion onto the rootstock. There are more heat tolerant, as you mentioned, some of the varieties from Spain and Italy, for example, are more heat tolerant and more drought tolerant. And so those might be possible options. Now, of course, if you have an established vineyard, you're probably hearing me and going, oh, rolling your eyes, thinking, well, this guy's out to lunch. But there are other aspects for, established vineyards. A lot of vineyard soil management can come into play here. Increasing the water holding capacity of the soil, whether that's through the addition of organic matter, can help, in this case, a vineyard become more water efficient. And hopefully that will offset the decrease in efficiency that warmer temperatures are driving. But so you have from the vineyard soil, the selection of cultivars, whether it's the rootstock or the scion, and this is the case too. Again, going back to a new planting, you can think of the direction your trellis, your rows are running, east-west instead of north-south. You can think about how the canopy architecture or structure is going to be such that the fruit are not exposed to a lot of sun and suffer heat stress impacts. So there really are a lot of different tools that are coming out from places. A lot of it's coming out of Europe. There's a lot coming out of California as well. Now, again, the question is it applicable here? And I kind of said, well, not all of it's going to be, because of the unique conditions here. But again, it's trying to figure out what's in the catalog, what we can use to address our situation here. And maybe with some of the research that we do, and some of the trial and error in the vineyards as well, is going to give us some new options that other regions aren't trying. And personally, I really think that given the current conditions of Arizona in terms of growing conditions, there's a really big opportunity to export knowledge to other warm climate viticulture, other warm climate wine grape growing areas. Some new technologies, new approaches on how to handle the problems that we might be encountering here, or potentially in the future, how we deal with them. Other regions are going to be experiencing that as well. And so there's I think a really good opportunity for Arizona, even though the challenges are going to be there, to overcome them and then kind of get on the international stage as far as being, hey, this is one of the areas that other parts of the world that grow wine grapes can look at for possible solutions. I mean, Europe already is looking heavily at Israel and the wine grape growing industry there to see what solutions they're offering and coming up with. So I think, yeah, there's a big opportunity there.
We had a question from one of our audience members, Warren. He was asking, are heat mitigating vineyard controls being considered, such as micro sprayers to cool the soil surface to decrease the radiant heat to the vines? And he mentioned this could be effective in dry conditions when mildew is not a concern. Of course, here in Arizona, if we have a typical monsoon season, that's one of the challenges we have is monsoon, because of the higher humidity and precipitation. We battle mildew, and I did a quick Google search up in Yakima Valley. There's a vineyard, Alder Ridge Vineyard and Estate, where they are using these micro sprinklers. When temperatures reach 95 degrees, they place it under the canopy, and they only do it within their 3-acre block of Barbera wine grapes. The sprinklers actually cool down the block on average about 5 degrees, but at times the Barbera grapes were 8 degrees cooler than the other blocks nearby without the sprinklers. This was an article that was published in 2006, and at that time they had tried that method for 3 seasons. But of course, that strategy uses a lot of water. In their case, they were pumping 4.5 gallons per water for each micro sprinkler nozzle. So anyway.
No, I'm glad you brought that up, because I've seen that research come out of Washington State University as well. And Yeah, there's an effect there that might be seen as beneficial, but of course, in a practical sense, it's what's the water bill going to be like?
Right.
And is that something that is digestible or palatable? Um, but it really points to the kind of the big issue here, and that's kind of like, well, how do you cool a vineyard in a way? How do you make it such that the fruit aren't uh, ripening under as high of a temperature? And so, right, you could start to think of the canopy. You could start to think of, you mentioned there the, wetting the soil and having that evaporative cooling basically happening in the vineyard. Some say cover crops are another way to do it, to help adjust and control, to an extent, the temperature in the vineyard. Cover crops, and here in the Arizona, of course, are that might be kind of tricky because our precipitation is, we can go a few months without precipitation. To expect the cover crops to last through that, well, they're either going to go dormant and they're going to die. And, under neither of those situations are they going to be transpiring water to cool the vineyard. So nonetheless, having that cover crop may keep the vineyard soils, a bare soil, for example, from absorbing as much sunlight during the day, therefore not warming up as much during the bulk of the summer, and having that be part of the vineyard temperature. So again, it's not some of these solutions might work here, some might not, but I think in terms of dealing with these new challenges, it's worth assembling a really good toolbox.
So now let's talk about some of the research and projects you're involved with at University of Arizona. Let's start with the Climate Viticulture newsletter.
Yeah, that's been fun. It's it's, I always know when the end of the month and the start of the next one are, because I'm scrambling to put those together, but that's okay. I enjoy doing that. It forces me to carve out some time and think about these issues, which I really like to do. It's something, for those that may not know, the issues come out monthly. We started back in May of 2019, I believe. And it's just a really quick hit on some of the climate topics that may be timely at whatever part of the year we're on. And so we'll quickly recap the past month in terms of temperature and precipitation. Again, people might be in the vineyard or doing other things, super busy, not wondering, or maybe they're so busy that it's hard to remember what exactly the whole past month was like. So just to refresh the memory so that when you go out in the vineyard, at the beginning of the month, you can kind of put it in context of what things were in the previous 30 days. We also show some of the monthly outlook information that the National Oceanic and Atmospheric Administration, their Climate Prediction Center, I believe is what CPC stands for, that they put out. And it's just to give an indication of where, the forecast agencies at the national level are thinking, in a probabilistic sense. Are we leaning wet or dry for the next 30 days? Are we leaning warm or cool for the next 30 days? Or are we going to, most likely be normal? That's another option there, right? And, in both of those cases, it's kind of fun because I've really tried to put myself in the shoes of somebody in the vineyard saying, okay, how might this information actually be something I want to think about? How is it going to tie into what I'm doing? So for me, it's been fun to, try as best I can to put myself in the vineyard person's shoes and try to find some relevancy for that information. Coming up in the next couple months, one of our big topics outside of the past and upcoming conditions is going to be looking at bud break and the start of the growing season. So we're going to be focusing a lot on chilling and heat units and what they've been doing for us this year and how they compare to previous years. So the ultimate goal there is to try to come up with a good model for predicting bud break. Is it going to be relatively early, on time, or late, given whatever conditions we might have had in a given year.
Right. And so, Jeremy, is this newsletter available to anyone who's interested in it? It's
You bet it is.
Okay.
Yeah. I just need an email address and permission to sign a person up. And
okay. How should they
so.
How should they request that? Should they contact your email address, or?
Yeah, they can send me an email if they're interested. Do you want me to put that in the chat?
Yeah, please. Yeah.
Sure. Yeah. I also have all the past issues of the newsletter online, because I often refer to previous bits of information in any given current issue. And so, yeah, if you're on the website, you can sign up there as well. But easiest way is just to send me an email.
Okay. And so next, did you want to talk about, is it VCore? Is that?
Yes, I'm glad you brought that up, because it ties into some of the things we were just talking about in terms of what are the heat tolerant varieties, what are the drought tolerant rootstocks. Maybe somebody is needing a rootstock that's tolerant of salinity in the soil or whatever other conditions. And once I put those two together and put them in my vineyard, are they going to give me a good grape that's going to make good wine? Those are big questions. And so the VCore project is, VCore stands for Viticulture Center of Research. And the group I'm working with on that later this year, fingers crossed, given the pandemic, nothing's totally certain, but we're hoping October, November, sometime late in the fall after harvest and crush, to have a 2-day workshop. We'll be having plenty of conversations with growers well before then to make sure that once everybody does get to this 2-day workshop, we have some substantial things to put together in terms of where such a center would go and what it would, in terms of what it would do. What are the big Arizona viticulture specific questions that we need to have answered? And so that's going to be kind of the basic center and what it does for research. So that's something that in the newsletter, I'll provide any updates that do come along when they come along. And you'll probably be hearing about it through other sources as well. But yeah, maybe some of those variety trials, water use, what is optimal irrigation on some of these, or required irrigation on some of these varieties, those types of questions. Perhaps we can answer them at this center.
So this will be a 40-acre, is that correct? Planted out vineyard. It's in Wilcox, is that correct?
It's right south of Wilcox, in the Wilcox AVA, down towards Kansas Settlement. Private group has 40 acres that they want to donate towards a viticulture center research. And at the present time, 10 acres will go in, I think, is the first, it's a kind of a progression or a phased approach, if you will. So 10 acres would be the starting point there. And right, this 2-day workshop is to get all these ideas, fine-tuned that we come up with during conversations and discussions over the coming months, and give that center some really good, solid direction in terms of what the needs are. And also going on behind the scenes are ways to help, other funding ways to help make this happen.
And so right now in this phase as well, you're getting the Arizona viticulture and industry involved in terms of their letters of support, right?
That's right.
Demonstrating the backing of this.
Yes, that's right. And it's really to demonstrate the level of interest that's out there. And it's not going to be just Arizona. It's definitely going to be focused here, located in the state in the southeast corner. And but nonetheless, we're going to be talking with New Mexico and having those, Gil Giese is the state viticulturist there. He's going to be part of our conversations. And in terms of the research, we're hoping he can, be part of the research team on projects and things like that. So it's really, and expanding, Western Colorado has some wine grape growing areas. Utah State, people from there have come down to our state's annual symposia before. So, and maybe even some parts of extreme Southern California that, tend to run warmer than most of the rest of the state. Or Temecula, I believe, maybe some of those areas could also be part of the discussion to really get at some of these warm climate viticulture questions that we're asking.
Mm-hmm. Yeah. And how about your geospatial web application? Can you talk about that?
Ooh, put me on the spot. Well, yeah, so it's, looking back over the past few years, just the, as I mentioned early on, just the diversity of projects. And, during those projects, I've come across various different data sets. A lot of them are geospatial, or, basically, if you can imagine them plotted on a map, right? And so I have, I think, a pretty good, knowledge as far as, what's out there. And now that I've gotten into the climate and viticulture work, I can see, okay, what else is out there that might be relevant here and potentially useful. And I've put some of those climate, soil, topography type variables together for the 3 AVAs of the state. Topography being things like slope and aspect and elevation, right? And so, yeah, the web map application is kind of the next step of that project. And it's really an evolving project where I don't have an end date. I just let it grow as, the information comes out, the data sets become available, and people like folks on this call today, say, hey, is there a data set that looks at this? And oh yeah, sure, I'll put that in there. And it's going to be initially for the state of Arizona. So if you're looking to figure out, I want to put in a new vineyard, so hopefully this is a tool that would help you out in terms of, what characteristics of a location, you want, hopefully we can find them and go from there. So, and I'm hoping that, of course, there are other applications too. And like I said, it's something that just is evolving.
So is this something that's in development right now, not available, or is there something available that people can access right now?
Not available. Well, I don't want to make it available. Okay. I have been working on it this week a bit, but soon I hope to have something at least, basic up so we could start to put these data sets together, take a look at them, and from there, improve the interface, try to add features that people want, add information that people want. Yeah, it's kind of just an ongoing project that hopefully will be helpful.
Okay. And what's the, so we've got the newsletter, of course. So will a lot of information about your current research and projects, will that be shared through the newsletter, or are there other ways to keep track of what you're involved with?
I think the newsletter is a good place to find that. Okay. Sometimes the pressure of the newsletter gets me to, having something in it worth reading, gets me to work on these topics. And it might just be a relatively simple analysis of one thing or another. Over the past few months, for example, I've been taking a look at some of the climate projections for the 3 AVAs in the state of Arizona in terms of things like growing season temperatures. That's the average temperature from April through October in this case. And yeah, so some of the stuff I'm working on, I or actually probably all of it, I'm going to end up putting in there at some point in time. And other than that, I try my hand at Twitter from time to time. I don't know if I'm that good at it, but I really just keep it pretty well dialed to what I'm working on. And so that's another place where people can keep track of what I'm working on.
And what is your Twitter name?
The handle?
Handle.
Oh, gosh. Let's see. Let me open up Twitter. I think I know what it is, but I want to confirm. I think it's, yeah, all right. I think it's going to be, there we go. And that is, all right. And if I don't come up there, my apologies. I'm pretty sure that's my handle.
Did you put it in the chat?
I put it in, oh,
Okay,
yeah, yeah, there it is in the chat. Yep.
Okay. So let's see. So what are your thoughts on future projects that you'd like to see happen or need to happen?
Yeah, well, certainly, having that viticulture center of research would be huge. Not only from my perspective and what I work on, but from so many others, from soil science in the vineyard to the, variety selection to even thinking about some of the pests and pathogens that affect vines in this state, and treatments on them, for example. So, that I think would be incredibly valuable. What else am I thinking of? Yeah, we mentioned the web application. That's something I really want to get done as well. Yeah, I just have a huge list. I'm trying to think of what's more pie in the sky in this point and what's actually something tangible. One thing I'd really like to get back to, and it's been put on the back burner for a few different reasons, but it's looking at, it's an analysis approach or methodology that can help us better judge the risk of events like spring freezes as we go further into the future over the coming decades. And the bones, the kind of the recipes there for doing that analysis is complicated. So I won't get into the details, but thinking about analysis that helps us get a better handle on what is the spring freeze risk? Is it changing? How is it changing? Similarly with fall, the last 2 years we had freezes in mid-late October in some of the regions, and it's that hadn't happened for 5-10 years, I think, if I remember the data right. So that's a question there too, and you want the vines to go into dormancy on a nice schedule. You don't want them to be shocked into it. Right. So taking a look at aspects like that, and really generating that information that if the risk is decreasing for spring freezes, for example, and I don't know this, but as an example, hypothetically speaking, that might, do you put in a fan machine or not? Decisions like that, may consider that information as part of the overall decision-making process. And if we can come up with that, then I'd be happy to have accomplished that. So that's one thing I'm thinking about. Okay. Hopefully we'll get there soon.
So we've got questions here. Let's see, I think some
Great.
Answered already, but let me take a look here. So there's a question about have El Nino and La Nina patterns changed in the past 20 years in terms of magnitude or frequency?
I think that is a really great, great question. And I think the science is pretty active there. It may be kind of cutting edge type science. One of the reasons why is that we have a relatively short historical record of El Nino and La Nina events in the observations, right? Ship data, satellite data, those types of things. And so Yeah, I think climate science, generally speaking, is trying to figure that out. Now, there have been some really big El Nino events, 97, 98, 1983. Those are two examples. Are those becoming more frequent? Tough to say with such a small sample size, I think. But definitely in terms of climate change, that is a question that is being looked at pretty intensively because El Nino and La Nina events affect climate worldwide. Almost every continent, basically every continent has some type of impact. Almost every continent has, some type of impacts, whether it's increased drought or what have you. So a lot of people are interested in that question. And I think, we just don't have a really clear answer on that yet, as far as I know.
Mm-hmm. And there's a few questions, and we kind of touched on this, but in terms of viticulture, growing grapes in Arizona, over a 50 to 100 year period, do the models potentially indicate that viticulture is no longer viable in Arizona? Or do we know at this point?
Do we know? Well, I think that is pointing to a really big issue, and it's one of the reasons why I think the topic is so receptive by people like all of you in viticulture, is that, as the question alludes to, when you plant, you're expecting to get to at least 2 to 3 decades, if not longer, production out of those plants. It's a long-term investment, and if climate is changing, then all of a sudden, you can imagine how conditions when you're planting today might be different from conditions that you would experience at that same location in 30 years' time, for example. Mm-hmm. And so it's actually something where I think that Arizona, especially it's a young growing industry, growing in the sense of acreage increasing, especially over the last 5-10 years. That with the new vineyards, with all that we already know about climate change, we don't know everything, but we know a lot, and we know enough to help to use that information to help make decisions, as far as which varieties you choose at this point in time, and thinking ahead, 30 years, I still want these vines to be productive. Knowing that the growing season temperature, the temperatures under which the fruit ripens are going to be higher 20, 30 years down the line, that might influence your decision to find grapes that are more heat tolerant, for example. So you can use, I believe, right? Of course I'm biased because I do this kind of work, that information can be part of the decision-making process if you're putting in new plantings. But to go back to the point of viability, I think that before we get to that question, there are a lot of adaptation tools that we've been talking about over the conversation tonight that might come into play. And so even though the temperature conditions might not reflect, might make you hesitate as far as putting in a vineyard in 30 years, because maybe temperatures are too warm. Drew, you mentioned how Phoenix and Tucson, you just don't grow quality wine grapes there because it's too hot. That's true. Maybe some of these adaptation tools that we already know and we put into place, or that we develop here in Arizona, can effectively buy us some time and extend the viability, in this case, as the questions posed, of a location supporting a quality wine grape vineyard. So I don't I don't like to answer that viability question because we're talking about people's livelihoods here and their ties to working in the industry and such. So unless we have a really good answer, I'm not going to answer that question, and I don't think we have a good answer there yet.
Right.
I think we got a lot of tools to potentially work with to find solutions that keep us going a little longer than what we might expect or guess at this point.
Do you know if there's been any research on how quickly a grapevine can adapt to, the plant itself can adapt to changes in temperature and climate?
I think in terms of genetically, the individual varieties probably aren't, if you have a specific variety and clone, I think the range of optimal growing conditions is probably pretty well set. That's not going to change over the lifetime of that individual plant. But, in thinking about different rootstocks, different clones of a same variety, you can start to open up the range of possible conditions that a particular wine grape might grow. And so, again, that goes back to, well, what are those varieties? What are those clones? Do we know? And I don't have the answer to that. But those types of questions, maybe somebody has an answer for a particular variety. Hey, this clone works better. This clone of wine grape backs did relatively well last summer when it was record hot. But this other clone did not, the same wine grape. And so there may be some observational evidence coming out of the vineyards that can help us accumulate this and aggregate this information. The Center of Research, the Viticulture Center of Research, that's another question that, if the industry sees that as being one of the priorities, and hopefully someday help address.
Well, and we know, I think it's the University of Minnesota, they've developed a number of hybrids that allow wine grapes to be grown in, those colder northern regions. Perhaps something similar can happen for the warmer regions as well.
Yeah, it's definitely possible. I mean, the cool climate viticulture gets a lot of attention with research. Warm climate viticulture, not so much. That's just my informal survey of what I see in the literature and whatnot. So there's opportunity there to generate knowledge that can help these areas continue growing wine grapes. Again, that's an opportunity for the state, I think.
Here's a question: is the University of Arizona School of Agriculture involved in adaptive agriculture to try to address the type of crops and varieties of plants that can thrive in a region if these changes do happen? In other words, grape varietals that can thrive in drier, hotter regions, etc. Well, it sounds like VCOR will be addressing some of that.
Yeah, hopefully, if we can get that project off the ground, that would definitely be the place for that type of research for wine grapes. I do know, I don't have the details in memory, but I do know, other types of arid land crops are being researched through different faculty at the University of Arizona to see which ones do better in things like hot, dry climates, saline water, saline soils. So that type of research can be transferred from other crops, the way they do the research, into the wine grape world, and hopefully that would have some good potential results there for finding solutions.
Mm-hmm. Yeah, and this was a comment just to clarify. So the question is, are these statements true? Number one, historic weather data is what has been used to construct historic climate change. And then, go ahead.
Sure, we'll do them one at a time. That way I make sure I remember them all. Using the observational data sets, which go back roughly 100 years, say, plus or minus, depending on the records. The observational records, you do see trends in things like temperature, for example. You do see trends in extreme precipitation amounts as well. And so, yes, we are seeing signs of what we would expect from climate change occurring already in the observational record. So you can think of, just generally speaking, 1900 to 2020. So the second question, or are there a couple others on that?
Yeah. So the second, or again, asking, is this statement true? Climate forecasts take those historic trends and extrapolate them using known climatic influencers such as Earth movement cycles, greenhouse gas, historic projected quantities, deforestation, historic projected trends, etc.
So the climate models, again, it comes back to, let's see. I'm trying to find that question just to make sure I understand it.
It's about midway down.
Okay.
From Mark Dallas.
Yeah, the climate projection models, in these global models, are looking at changes in forcings or things that we know to affect the overall energy balance of the climate system. And so again, things like solar variability, volcanic eruptions, but also greenhouse gas emissions. And now part of the land surface models in those climate models can mimic deforestation, and to the extent possible, they are, as far as I understand the research, again, it's not something I actively do, but my understanding is that they are incorporating some of these observations that we do have and assimilating them into the models to give them kind of tie points, if you will. And it's not entirely seamless at this point, but where the observations are used, I know, though a lot of that does go into weather forecast models that are telling us, okay, over the next few days, 1 week, 2 weeks, what we might expect for our weather. So again, they're two different beasts. They're kind of looking at the same thing, but kind of not. And it's, I'm apologize if I just didn't quite describe the nuance there between them, the differences between them. But the activities are slowly getting closer and closer together in the sense of, just one big model. We're going to use it for everything, but we're not there yet.
Mm-hmm. Okay. Next question. Do you know of specific labs or universities, colleges doing climate change science specific to, special plant breeding and genetic research and such? So U of A, of course. Do you know of others that are doing this as well?
Wow. Plant breeding. Certainly, they're going to be taking that into effect. I would, offhand, I don't have any examples, but I would recommend simply searching for the, universities, colleges of agriculture that do breeding, that do look at genetics, and see if there are individual faculty members that are doing those activities, that research in the context of climate change. And perhaps they're growing them in controlled environments where they are changing the temperature ranges under which the plants are grown. They might even be changing the CO2 concentrations to see, hitting the system really hard and saying, okay, if we really shock this plant with a lot of CO2, does it develop differently, and does it behave differently? So I would recommend looking around. I would be shocked if nobody is doing that. Put it that way.
Yeah. Do you know, are you or other scientists at U of A that are looking at climate as it relates to viticulture? Are you? So the question is, what do you recommend from vineyard operators in terms of data collection? Do you collect data from individual vineyards?
I would love to. In terms of data collection, if you have data sets, maybe you have a weather station, you want to start, and you've had it there for 5 years, and you want to start, getting a better idea of average conditions, extremes, potential ranges, heating units, that kind of thing, or other observations in the vineyard related to phenology would be key. I mentioned the bud break modeling work that I'm starting to scratch at these days. In the literature, scientific literature from other regions, they've been working on developing phenology models to predict not only bud break, but also flowering and veraison, or the start of the ripening period. And so the phenological observations or growth stage observations, the date that they are occurring in the vineyard, can be super helpful, because then we can tie that to some of the temperature data to see if how much heating, how much heat units are needed to reach those growth stages. And we can get a better idea as far as what we might expect, in a predictive sense, in any given year. So those would be two real valuable areas. And in my position as cooperative extension, it's within my realm to help people out. With that, and I've done it for growers of annual crops, where I take their field data and integrate it with some of the temperature data, and we try to make sense out of things. And just so we can get that extra bit of insight as to what's been going on and potentially why in the context of the growing conditions.
Okay. I kind of scanned through the questions here, and I think we answered the question. There was one last one. Every summer I watch the NOAA data for tropical storms off the west coast of Mexico. It seems that most go due west into the Pacific Ocean and not to the southwest USA. Is this a more recent phenomena, and how does that relate to the southern oscillation pattern?
Yeah, good stuff, because those tropical cyclones can save us if we have a dry summer, but then again, if they happen right at harvest, can be paid in the neck for somebody growing grapes.
Yeah.
There are some links to El Nino Southern Oscillation, or the phenomena that produces El Nino and La Nina events. And it really has to do with the sea surface temperatures off of the west coast of Mexico, and some of the other factors of the environment, like the amount of shear in the atmosphere. Are the storms able to form, or do winds in the upper atmosphere tear them apart before they can? You've all probably noticed that those tropical cyclones, they often just kind of float out west, from where they start off the west coast of Mexico. But in September and October, generally speaking, that time of year, sometimes they curve back up to the north and the northeast and come into our region. And it has to do with how, what is steering the storms when they are living, if you will. And so the jet stream, as you know, during the summer, June, July, August, it's nowhere to be found around here, right? We're under the high pressure system, the monsoon high, as it sometimes is called. And that, helps push things away from us. That's why we don't see them curve to the north. We can get some of the moisture flux up the Gulf of California, what they call a Gulf surge, that some of you may have heard of before. Some of that might leak into the region during the monsoon season, but we really don't get the storms recurving. The storms recurve in September and October, typically because the monsoon high is retreating southward. We see a little more presence and influence of the jet stream in the region in those months, and basically it helps steer storms into our region.
I think we're at the end. Thank you, Jeremy, for hanging out with us for a bit and discussing a topic that's really important to the local community, here in the Verde Valley. Climate change and viticulture. We appreciate your time. And I just wanted to say, in the next day or so, look out for an email asking you to complete a short survey. Your feedback is very important. and that will help us determine what you'd like to see in a future Science Cafe. Right now, we're planning our next event in April, so look out for an email invitation, and please invite your family and friends. As always, the more the merrier. Thank you all for joining us.
Drew, quick note here.
Yes.
There are some questions actually coming in the chat.
Oh, okay.
So if you want to just really
go
through them quickly.
Yeah, let's do that.
Okay, so somebody mentioned the Washington State Network, Growing Degree Days. They also have some cold, I'm just reading from the bottom up, my apologies. They also have some cold damage to vineyards literature out there, and that might help answer that Texas Hill Country question that Dennis asked. That's an open question right now. I've seen that on the social media where people are starting to wonder, what the cold snap in the center of the country this past week is going to do for viticulture in Texas. Question on, I'm sorry, Drew.
No, go ahead.
Grab the steering wheel from you here.
No, I'm trying to catch up here. There's a lot in the chat I didn't see.
That's all right. Existing AVAs, suitable higher elevation or cooler adjacent areas. Some do and some don't. And I mean, for example, the Wilcox area, you have the Sky Islands nearby, but it's tough to find anywhere to plant up there because it's all Forest Service. Sonoyta is a bit higher. The AVA is a bit higher than the Wilcox AVA in terms of elevation, I believe. And so there may be some relatively cooler areas there as well. Again, it's a lot of Forest Service land on the Sky Islands. In the Verde Valley, certainly you can go up in elevation in adjacent areas. And yeah, I guess, make a long story short here, that's one of the reasons why I'm putting together that web map application, is to start to compile this information so that we can ask questions like Warren did here, as far as, where are these cooler, higher elevation areas that might be suitable for growing wine grapes?
Let's see. There was a question about citizen scientists. Are there opportunities for members of the public to help out with some of the projects you're involved with?
I imagine there are. You've seen citizen science really come into its own in the last few years in various aspects, various topics. With viticulture, yeah, I mean, we've talked about, if you have data there that, from your vineyard that needs to be, that you've been collecting, you're basically being a citizen scientist in some way, right? And again, part of my responsibilities with Cooperative Extension are to help people make sense of that if they need a hand doing so. Volunteering with Cooperative Extension is, and there are a few of us that are working in the viticulture realm. That might be another way to start in on that type of aspect of viticulture. I don't personally have any formal programs started yet, but that's a good question, and I bet you I'm going to be mulling that over.
Put that on your list. Huh?
Yeah, exactly.
And I see a question regarding Yavapai College. So the question is the college's vineyards irrigated? And yes, we do irrigate at Yavapai College, and we actually use reclaimed water, high-grade reclaimed water from the city of Cottonwood. And I think, you see anything else here?
I think we
Jeremy, I think we covered it, huh?
Got it. Yeah. Yeah.
Well, again, thank you so much, Jeremy. Appreciate it. Thank you all for joining us. I guess that's it for now. Good night, everyone.
Yeah. Thanks, everyone.
Yeah.
Hopefully, the conversation was good, and have a great weekend.
Yeah. Take care, everyone.
Good to get in touch.
Good night.
Bye.